This will be taken from these first 4 lectures. Make sure your content is about Hive, and this will be all right. So let's start. Let me share my screen. Can you see my screen?
Yeah.
Okay. So you have a couple of things that is due apart from the assignment. So as you all know, you have gone through the syllabus. But this week you are due with your first quiz. Today we'll be done with our 4 lecture. So the quiz will be from first 4 lectures. That is the first that is you did the U and its visualization Cloudera, and then the second lecture was related to the Hadoop and its components, that is HDFS and MapReduce. And the third was the advanced algorithms using the MapReduce paradigm. And then we have today's lecture is about Hive. So the first quiz will be taken from these first 4 lectures. Make sure your concepts and everything are clear. So you have to take the quiz through Canvas. The deadline for the quiz is this week, Friday. The quiz will be uploaded soon, so make sure you meet the deadline and complete the quiz before the deadline. The quiz will be remotely taken through the Canvas, so make sure you attempt it correctly, um, and you meet the deadline. Most probably the quiz, the instructions and everything will be given there, but the mode of the quiz will be objective type. That is, excuse me, it will contain the multiple choice questions or true false or match the column, or it can be any fill in the blank type questions, so or multiple choice. So these type of questions that is more related to the objective, not to the subjective type questions. So you have to take that quiz through the Canvas. The deadline is coming Friday. Okay, that make sure you check your Canvas and attend the quiz before the deadline. It will be uploaded soon. The second thing is the project proposal. Since this is the project based course, and also we'll take the exam from the project and also from the lectures that you are studying and will be studying the rest of the lectures. So we will have pre-exam and one final exam. That's what we discussed already earlier, and also we have gone over the syllabus. So the project proposal, that's what we call as an increment 1, is due on February 26th. It is already published in the Canvas. Make sure you are able to see the Canvas publication for this under the Your Project section. So I will quickly go over this, and if you have any question, just then let me know. I will quickly go over this. Make sure the project will go incremental wise. It will change with time. You can add more things to it, and the complexity of the project should be enough for the one whole semester project. So let me go over this quickly, and then I can guide you how you can select your projects based on your Hadoop or Spark programming, what you're studying. All right, so the proposal should contain the following things. Let's say you have an idea. You can get idea if you are unable to get any idea, let me know. But I just want to give you a choice so you can search and have an idea that you can work in Hadoop and Spark programming. It can be any environmental issue or anything. For example, you want to work on the COVID data or any type of the data you want to work on. So this will be all about using the MapReduce. So make sure the first part you will be doing is the data collection part. So one of the most familiar or famous website is kaggle.com. There you can search for tons of the data, but make sure first you select the topic and then according to that you search for the data. So your first job for the project will be searching of the data based on your topic. So once you are able to search that, after that, what you need to do is, because you know, like why you want to work on that particular topic. For example, you want to work on the, let's say this is just one example, you should not limit it, you should not be limited to only this project. So let's say you want to do the COVID data analysis for the past year 2020, let's say, and you want to get the data for that. It can be live data, it can be real time data, or it can be any existing data that can be used for the analysis purpose. So why you want to work on that data, what is your goal and objectives for this project, why you got motivated to select the COVID analysis, what is the significance of this project, and then objectives. For example, what will be your objectives? You want to, for example, do the pre-processing of the data initially, and then your second objective can be applying the queries and then clean the data, or get the just relevant information out of the data, or get the relevant features from the existing data, and then apply the some analysis and analytics using the existing tool and technologies what we will study. So at this point it might be a little bit tough for you to make a decision because you haven't gone over all of the topics. But since you know you worked on the, for example, just the basics program, or the basic example like the matrix multiplication or breadth first search or depth first search. So these types of algorithms you have already applied on any of the data, and you know like how these algorithms work, why how mapper is useful and how reducer is useful. You have mapped the data or transformed the data, all of the data. Then you have also transformed the data that was starting from the letter A. So you have seen like, okay, if you use the mapper, what will be its significance? If you use the reducer, what will be its significance for transforming of the data? So you have worked on that. That is the actually the technical part. But now since like you will be covering this lecture also, that is mostly that is related to the query language, so then many of the things will be clear with time. But since our project will go incremental wise, this idea can be tentative. It can it can be incremented with time, or I can also add some parts to your idea once you post your ideas or your project proposal. So if it is required, I may add some part to it, or maybe remove some part from it. So it depends, because as I said, like this will be tentative. It will be not as your permanent or you can say like fixed project. You will work on the same and exact idea. But if your idea is good enough, that should be okay for the semester wise project according to its complexity. So then we may go with your idea. So make sure like you have 4 members in a team, and who are like the undergrads. Some of you have undergrads, 2 or 3 members in a team. So only those have 5 members, rest of you have 4 members. So make sure you divide that work equally among your teams. All right, so this is the, once you go over this document, this is the link is already available in the Canvas. The project proposal increment 1. Once you go over this document, make sure the deadline is February 26th. So here you don't have to do any technical part. However, you have to write a report. This is more like in the writing phase. It should include these headlines, for example, your project title, and then team members in your team, name of those members, then goals and objectives of your project, motivation, significance, objectives, and features. For example, you know, We have given you a syllabus, you know the content of the course. So for now, what you can do is you can write the Hadoop part, and from the features, you may write the Spark part, because one more thing I want to mention is you cannot work only on the project that should be covered in Hadoop. You have to take at least 2 3 components from the first part, that is Hadoop, and similarly 2 3 components from the second part, that is the Spark programming. So you know the content of the course, make sure you include or you create a project that should include both. So have an idea about, okay, you know, like what we'll be studying in that, go over the syllabus, what we'll be studying in that contents. Make sure you create a project according to that. It should not be only in the Hadoop, it can be integration of both Hadoop and Spark programming. So make sure you include that in your features. Again, this is tentative, it can be changed for increment 2. For example, there might be 25% changes or 50% changes or 10% changes in your increment 2. So but this is just like how or what you want to propose or what you want to work for your project. So once you are done with the project goals and objectives, since this project is a story based experimental project, so you have to do some experimentation, and along with that, you have to write a story for that. How you will write a story? Make sure you go over this link. The link is given in this document. You click over this link, it will take you to the storytelling part. This is the assignment one, your assignment one. So you have yeah, almost 2 weeks from right now. So make sure you start writing on this. So this is basically the 5 chapters that will go over the semester. You will be we may skip one of the chapter, for example, let's say the society, which is not related to your big data programming subject. So we may remove these type of let's say topic. But this is like as an overall, it will go iteratively like that, how it will go. So the overall storyline focuses on 5W plus H. Who is it about? What happened? When did it take place? Where did it take place? Why did it happen? How did it happen? So this is a kind of like a storytelling part. For example, you have to answer these questions for your first increment, or you have to do this for each assignment. So for your first increment, your major task will be data collection. So for that, you should for this assignment, for this part, you have to describe some real world problem, and basically facing the targeted users or audience. So this is your objective one. We will share all of the later on, like for example, for increment 2 or final report, we will share all of this. It will go incremental wise, but for your first part, for first increment and idea, you have to work on the chapter 1. That is the, you have to answer these questions exactly. You can write this question, answer this question according to your project. So think of your project based on this story. Whatever project you are working on, let it be COVID data analysis, or you are using any energy data, or you're using any type of the data, make sure you should be able to answer this, and you should make an idea according to these questions. Like, what is the main problem? Where did it take place? Who are the people or community which are needing help of the specific project that you're working on, because you will be choosing some real world problems. And where mean two things, that is the environment and settings that the people or the community is living in, or the place or location where the problem took place. So it can be any type of that data. One another example is, for example, you are using the opioid data that is publicly given by the CDC, on the CDC, or that is also available on the kaggle.com. So you can just take that data and you can make a story for that. So opioid data is mainly, it shows the number of deaths, or the number of affectees that are over the past years that are affected by using the particular opioids. the name of the poets is also given in as on one feature, and then so on, so you can select those features later on the data. But how you can write the stories, who are the people communities in need of help, for if you're using, let's say, the poet data analysis, what problem happened to them, why is there need for using that, and when did the problem take place. So you can, the data should contain the number of the years, so you can just explain that in terms of that data. You can give these answers, whatever data you are choosing and whatever your project is all about. So why and then how. So this is all about your project increment one. It's more like a writing part. So make sure your contribution of work should be equally divided. For example, and it should not be mentioned like that. For example, if you're writing a project increment one, let's say, so whoever is writing this project proposal description, at the end of the, at the 4 point, as it say contribution of work, so contribution of work should be team member name one. It should not be like this. If you have four teams and you can write, okay, 25% team one, member one, 25% two, 25 3, 25 4. It, yes, it should be equally divided, but it should also give the headings, or if you can say like the work, what work is done by which team member. For example, the project proposal description, or the storytelling parts, the few questions for the storytelling part, that is divided. For example, two of these or three of questions are done by one member, three are done by second member, or the whole chapter is written by the chapter one, let's say, by one member, or the project the proposal description is run by the another member. So it should be like equally divided. And also later on, you can also divide the work in terms of the technical and then writing part, and then also the one who maintain the GitHub repository. But it should not be like that, okay, just one is maintaining the GitHub repository and the rest are doing the technical or the report part. So the main point is equally divided like that. But again, it should not be just written as the 4 point. If you just write the contribution of work is 25%, 25%, 25, 25, it doesn't mean everyone will get equal marks. So make sure you have to explain what is done by which team member. So then once you are done with this, here is the Google form. Here is the form. You have to use this form, and you have to submit the link to submit your proposal for the project. For the whole project, you can use your own GitHub repository. For the ICP, we are providing you a repository where you submit your work, while for the project, you can use your own repository. Any team lead can use his repository and add collaborators, for example, other team members as a collaborator in your repository, and then just submit us one link. Make sure you submit your proposal to Canvas Turnitin. A link is already provided to you. One submission per team. Any team lead can submit, but it should be one submission per team. That is, the report should be submitted, and make sure the similarity score should be less than 15%. So the last point here, the fifth point, was the references. If you are using any references for your write-up part, or you have searched any data and you're using any reference for that, because now we don't want data from you. However, we just want an idea which data you want to work here. You can use that reference. You can put reference in that, in the fifth point. So that's all about the project proposal. Apart from this link, the Google form link, I will share another link with you, because we will put your projects on the OCL AI website. So that will be posted there. So I will also provide you another form. That is the two forms. You can use this form and also another one where you have to post your ideas, and you can just one team member can post the idea of the project. So that's all about the project proposal and increment one. If you have any question, just let me know. You can discuss it with your team and just let me know if you have any question. So we will start the lecture, and if you have any question, just let me know, in your breakout rooms, so I'll be able to answer there. All right, so that's all about the assignment one project. And then, so we have discussed the quiz, we have discussed the project. Now we are moving forward to our lecture 4. I hope all of you have got your grades. Some of you did not get. I have received the queries, and also you'll be getting your grades soon. So, yeah, and according to the rubric, so I think the TA will be able to um, grade you soon. So it should be available on your Canvas very soon. All right. So now we are moving to the Hive, which is much, we can say, easier than the MapReduce. So normally in this lecture, we will be going over like why Hive came into being, what is the overview, its architecture, and then applications of Hive, then cons and pros, and then some of the data model, and then we'll see the related work. All right. So data analysts with Hadoop, we know like they cry because some of the Hadoop MapReduce is always very low level and requires customers to write the custom programs, while Hive is basically built on top of Apache Hadoop, which is mainly used for providing the data query and analysis. So this supports queries expressed in the SQL-like language, which is we call is as Hive query language, which are compiled into MapReduce jobs executed on Hadoop. Hive also allows to write the MapReduce scripts. So basically, if we write the traditional SQL queries, that must be implemented in the MapReduce Java API to execute the SQL applications or queries over the distributed data. But Hive provides the necessary SQL abstraction to integrate all of the SQL like queries, which we call as the Hive query language. So it also includes the metastore that contains schemas. You can update that schemas. That is also one of the benefit of using Hive, and statistics that are useful for data exploration, query optimization, and query compilation. So there were some of the limitations of the MapReduce. That is why Hive was built for that. For example, MapReduce, it is not reusable, it is error prone, and for complex jobs, there are multi-stage of MapReduce functions. So just like if you ask developer to write specify physical execution plan in the database. So that is why Hive is quite convenient to use. So, how and what was the motivation? So now we know like Yahoo worked on Pig to facilitate application deployment on Hadoop. So, why we are just comparing the components of the Hadoop, that was mainly used, like Pig was mainly used for the unstructured data, while simultaneously Facebook started working on deploying warehouse solutions on Hadoop that resulted in Hive. So the size of data being collected and analyzed in industry for business intelligence is growing rapidly, making traditional warehousing solution prohibitively expensive. So that is the reason Hive is mainly used by the Facebook, while Pig was mainly used for the Yahoo. And one another difference is the data is the unstructured for the Pig, while the Hive uses the structured data. So, as I said, the Hive is a data warehousing system to store the structured data on Hadoop file system. This provides the an easy query these data by the execution of the Hadoop MapReduce plan, since it is built on top of the Hadoop. This makes the unstructured data looks like tables regardless how it really lay out. So why it looks like tables? Because it's more related to the SQL type structure. SQL based query can be directly used against these tables, and this generates specify execution plan for this query. So this is the mainly Hive architecture, so which have different features. So the major thing that architecture consists of is metastore, driver, and then the compiler, mainly like the query compilers. And there is another also things like what type of optimizers are used, what type of executors are used, so the execution engine, and then what is the server which are used for the different interface, or it can be like CLI, or it is UI, or it is a thrift server. And then we have the client components. So the meta stores basically is used to stores the metadata for each of the tables, or you can here it says like so stores system catalog. So how it stores the system catalogs? So basically it stores the metadata for each of those tables, or it's we can say it's schemas, and it's also locations, and it also contains the metastore data, or the metastore also includes the partitioning the metadata, which basically helps the driver to track the progress of different data sets which are distributed over the nodes of the clusters. So we know like here the data is also stored in the traditional RDBMS format. Then we have the driver. So basically driver manages life cycle of hive query as it moves through the hive, and it also manages sessions handle and sessions statistics. So basically this acts like a controller which receives all of the hive query language statements, and it starts execution of the statement by creating the sessions, and it also monitors the life cycle and progress of the execution process. So this is the mainly usage of the driver, the component of Hive. Then we have the query compiler. So basically, this compiles Hive query language into a directed acyclic graph of map reduce tasks. So this is so the main responsibility is it performs the compilation of Hive query language. We can say like different queries, and this converts the query to an execution plan. That is the reason it is the compiler, the query compiler. And this plan contains the tasks or steps that are mainly performed by the Hadoop MapReduce. Then we have different types of, we can say, the optimizer or execution engines, where the component executes the task in proper dependency order, which interacts with the Hadoop. Then we have the also Hive server. So Hive server, or we can say this thrift server also. This is basically we can say the command line interface that provides a user interface for an external user to which interacts with the Hive by submitting different queries or instructions or the monitoring processes. So basically this thrift server, this allows any external clients to interact with Hive over the network using the different drivers, or we can say to network which are similar to the JDBC or ODBC protocols. So this is how the Hive architecture looks like. Then, if we go into more detail, it's the same thing like how the map reduce part is done, what is the metadata store, how is the serialization and deserialization is done, how the file formats is done, how the HDFS and map reduce works for the Hive. Then we have the sample query plan, which is mainly we will cover the some of the DDL and DML languages, which is the part of the SQL language. So those of you who don't remember anything from the SQL languages or RDBMS, that should be clear. So how the sample query plan works, how the mapping part and reducer part work. So here are some of the operations, for example, the filter operations, table scan operations, or reducer scan operations that comes under the mapper part. While for the reducer part, we some action is taken against those mapping part, so which is the it can be depends on the queries, so it can be join operators, select operators, group by operators, or different types of clauses that can be used under the reducer part. So this is the how mapping and reducing part is done in the using the Hive. Then some of the applications why it is useful, it can be used for the log processing, daily report or user activity measurements. It can be used in the data or text mining, that is the machine learning, where it can be queried, that is the training. For the training data, we have two types of data, let's say training and testing data. So for training data, we can use the Hive queries, and in the business intelligence, advertising delivery, and it can be also used for the spam detection. So these are some of the applications for Hive. Some of the pros and cons using the Hive. We will come over the Hive architecture. We have seen the Hive architecture. We will see how the tables and partitioning of that tables works in the Hive, or how we have what are how the data is organized in the Hive data models. So let's
Professor Girish here. I'm sorry to interrupt.
yeah.
So, do Hive have its own database or database management system to store the metadata of the files that we are going to, insert, or yeah, it depends on some other databases for that.
Hive has its own data warehouse.
Okay.
Yeah. So some of the pros and cons. This is how why we use Hive, an easy way to process large scale data. It supports the SQL based queries. It provides the more user defined interfaces to extend in terms of the programmability and execution of performance. It is more efficient, and it can also interoperability with other databases tools also. So it is scalable. And also we can, as I said, like we can edit the schemas in the Hive, which is also scalable for any type of the data. Once you create a schema, you can edit it according to the data and its data types, or according to the tables. So this is one of the advantage of using Hive. Then we have some of the disadvantages. It's not easy way to append the data. File in HDFS are immutable. Some of the future work is still going on, that is the in terms of the variables and operators. Some of the future work is still going on there. Then we have the Hive data models. We will see how data is organized in the Hive, that is the tables. We have tables, partitions, and buckets. We'll give one of the example which will be more clear. So tables are mainly it's the same like as it's in the RDBMS SQL-like structure. So it's analogous to relational tables. Each table has a corresponding directory in HDFS. Data is serialized and stored as files within that directory. Hive has default serialization, which is built in supports with the compression and lazy deserialization. And while you can also specify your own or schemas or serialization and deserialization. Then we have the partitions, how each table has can be broken into partitions. For example, using this query, you can see it creates the table which has the two columns, let's say sale ID and amount. The data type is given. The name of the table is sales, which is partitioned by country, year, and month. So each partitions will be split out into the different folders. Like let's say sales can be country or equal to, you can say which is US per year or 2012 per month. So on. So this is how you can partition. So the hierarchy of Hive partitions would look like this. For example, this is one of the example related to the sales in terms of the country, year, and then month, and then for each month there is some of the files. This is a similar example. You can also take another example of the university, like you have UMKC has different departments, or we can say SCE, School of Engineering, Computing and Engineering has let's say three different departments, that is the computer science, let's say, or telecom, or TCN, or we can say another is the electrical engineering. So each of that when has its student records. So your main let's say here we say Hive. This is not Hive base, please make sure it's Hive, it's just a typo mistake. So here we have the, let's say, the School of Computing and Engineering, SCE, and then we have different departments. Each department includes the records of the students which are stored in some of the files. So each file we call them as the, once the data in each partition is divided into buckets. So how those buckets, that is done in the, based on the hash function of the columns. So taking the modulus, for example, hash function modulus number of buckets will give you the bucket number, and each bucket is stored as a file in the partition directory. So the hierarchy goes like tables, partitions, and then the buckets. Going further, we have the Hive query language. We have the DDL, DML query. These are exactly, or we can say, similar to the RDBMS. We know like the data definition language, the data manipulation language, what type of queries can be applied. So, for example, initially you will create a database, then you create a table in that. For that table, you can alter the table, you can show the table or describe that table. So then we have the how you can update the table, you can delete the table or insert the table using the some of the, or loading of the table using the data manipulation languages. And queries, for example, select, group by, join, multi-table, insert, you can use these type of queries. Even the clauses, let's say the where clauses and all, is also almost similar. So this is the same thing, how you can use the serialization, you can customize the serialization and deserialization for any type of data. It can be unstructured data, or for example, you have different type of data like audio, video data, or semi-structured using the XML data. So you can customize it for that, based on your type of the data. Then we have the data types and how the Hive, yeah, Hive also one of the another thing is, apart from the RDBMS, we know Hive supports the complex types. So we have different types of complex data types, let's say arrays, lists, or structs. So that is also one of the advantage of Hive. However, once in that will come in the next part, but I can just since we are into that discussion, so I can quickly go over that. So we will be in the next lecture, we'll be studying the scoop, which is the to transfer the data between the HDFS and relational databases. So there the problem might occur if you have, if you are using complex data types. We know if Hive supports the complex data types, there is no complex data types in the RDBMS. So what, how you will edit the schema for that? So there one of the question comes. So this is the data types. You can use any type of data types using the Hive. So then query languages, how, what type of queries you can apply, join operations or any type of other operations. So those are more related to the I can say like the SQL. You are already available aware of the SQL, how the HDFS directory is created. Also, if your Hive directory, let's say Hive using the data warehouse, if it is memory is full, you can also um, clean that memory using the Hive warehouse, and you can just work on as many data as you want. So some of the metadata which are associated with the data in the table to HDFS directories. So these are some of the data storage, like Hive warehouse test table is a HDFS directory. All right. So since Hive is built on top of the Hadoop, so everything we'll be using for the with the HDFS. This is some of the analysis, how Hive, what is the usage of Hive at Facebook, statistics per day, and Hive simplifies the Hadoop. So this is some of the analysis which is not recently done, but over the past year it's done. So, for example, what is the amount of the data that is compressed per day, or how many people are using the number of the tasks that are run on the Hadoop and Hive. That is the usage at Facebook. And then Hive versus Pig, we have seen like, and also apart from the structured and unstructured data, there are also some of the other similarities and differences in terms of the language and also like the working type. So but we are not concerned with the HIP. We're big, we'll be just studying the Hive. So yeah, so you can just go over these similarities if you are interested in exploring the pig also. So some of the Hive commands practice for practice purpose, make sure whatever reference we provide you, you go over this. All right, so this is the in-class exercise. So almost like we have given you some of the queries. You have to apply one of the query by yourself, and also you have to use these queries. The answer is already given. This is the first data set. So this is the Hive commands. That is the use case, petrol use case. The data set is the petrol data. Get the data from this link, download the data. This is the creation of table in Hive and loading of the data. So we have already provided you the how you can create the table, how you can load the data into those tables. So make sure you use these commands as it is. Apart from this, since maybe some of you are using query language after long or haven't practiced previously, so we have also provided you some of the commands and queries. So make sure you have to implement these for this petrol data also. It is already given, but this is for practice purpose. So make sure you implement all this, and while in your documentation we will see all of the answers to the question. So this is question number 1. It's already given to you. So once you are in practice, you will be able to answer the question. So this is the first, this is the second, this is the third. Like the questions are already given out of the petrol data. Make sure you practice these. The one we will you will try one yourself. Here it says greater than 500. Some of you might get, in fact all of you will get the result empty results for this, because the data is not, the records is not 500. So you can just decrease the number. You can give any 300 number, you will get the records for that. Then we have the in class 2, that is the Olympics data set. So for the Olympics data set also, the loading of the data and everything is available. The also questions, answer questions and its answer here. It's say, if you see this query, it's available for this question number 1. Just practice this 2, 3, 4, and then you have to try one for yourself. Then we have the last exercise, that is the, you have to use these data sets and then you have to complete these tasks. This is for this we haven't provided you any of the queries. You have to generate and write queries on your own using the existing movie lens data set. These are the references. Make sure to explore these references so everything should be clear to you. All right, I'll create breakout rooms. If you have any questions, just let me know. If some of you, I got the chat, I will answer your question. Just give me a moment. Do not have team members available. So if they're not, please make sure you discuss the project ideas together and then work on the project idea. So once I'm just finishing the breakout rooms, I'll just open that. You can join. If you do not remember your team members, I'll also post them in the announcement, so you should know who your team members are in order to contact them for your projects. So if they're not available today, you can just contact them. Student, what is basically the serialization and deserialization? So basically, that might be a question for you all. So basically, serialization and deserialization allows Hive to read the data from tables and then write it back to the HDFS in any customized format. So that is one of the process in the Hive other than the RDBMS. I hope it's clear. So now I'm just opening all the rooms. Please join the breakout rooms. All right, so that's all for today. The quiz number 1 is already posted to the Canvas. You will be able to attempt it by tomorrow, and the deadline is Friday. So make sure you meet the deadline and you attempt it before the Friday, that is 11:55 p.m. If you have any questions, just let us know through email. All right.
Sounds good.
All right. Good night. Bye.
Take care.